Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right. Well, welcome everyone. Thanks for joining us today. So today we have with us Gabriella Gonzalez, who I only know from the digital world and this new world where we don't get many opportunities to cross paths in person. And the primary place where I encountered Gabriella was around Dhall, which we've talked about a number of times on the podcast. And we're like, okay, we got to have Gabriella on to talk about Dhall and declarative languages and all that fun stuff. But anyways, welcome, Gabriella. Thanks for joining us today.
Thank you. It's a pleasure to be here.
So we were, just before we started rolling, starting to talk about teaching functional programming, which is something that Bruce and I have been trying to kind of crack the nut on and figure that out. So I don't know, Bruce, what do we have to ask Gabriella?
Lots of books on this, and there's a few exceptions, and watching YouTube videos and everything. And it just seems like it's called the curse of knowledge, and people have, talked about the curse of, but apparently in pedagogy, there's this idea of the curse of knowledge. And I just see it repeated over and over again. People forgetting what it's like to come in from the outside. And so there's usually what happens is that they will say, okay, functional programming is good for this array of reasons. No real clear motivating factor, but just a handful of them. And you go, all right, maybe. And then they go, okay, and first you got to understand recursion so that you can understand how fold and those things are written. And you're going, I never use recursion, and why can't I just use a for loop? And the process of explanation just isn't compelling, and I think we lose a ton of people in the process because this is repeated over and over again. Every once in a while, I'll come across something where I go, okay, that's clearer. But so, what's your perspective on this? How do you think we should teach it?
Yeah. So first, let me preface this by saying throughout this, I'm going to be shilling a lot of my blog posts and talks because I tend to try to document everything I know to refer to it.
Sounds like a good idea.
So one of those talks I would like to shill here is how to market Haskell to a mainstream programmer. And it was written for a Haskell audience, but I think it would be useful for people who are trying to evangelize any language. It could be like Scala or whatever, what have you. And one of the key things is that I think one of the common mistakes languages make is that they try to position themselves as general purpose languages. And they may be general purpose languages, but that's not the way a newcomer to language will think about things. They're typically not coming to use the language for its own sake, but to solve a very specific class of problems. And typically the mindset that they approach these problems from is, what is the best language to solve this problem in? And they will use that. They'll ask their peers, like, I'm trying to do, data science. Like, what would you recommend is the best one to choose for data science? And maybe they'll say, Python, use that. So the question you want to ask, so you said, I think you touched on this when you said, a lot of the introductions are kind of missing the motivation. Like, what is the use case that will motivate all these features you're teaching? And the motivation is useful not just to get people interested in it, but also because very often, whenever using a language, you need to be kind of opinionated about it. There are many trade-offs you make when you're structuring, how to structure a project, what things to teach, what idioms to follow, how to architect things. And those trade-offs may differ from application domain to application domain. And so you can't give very clear and decisive answers for how to structure things if you don't have a clear use case in mind. Let me give a concrete example from the Haskell side, right? So one of the common controversies in the Haskell ecosystem is whether or not people should use optics or lenses. And in my view, the correct answer depends.
Can you explain what that is?
Yes. So optics or lenses you can think of kind of as first class getters and setters. And they're kind of like JQ for complex data structures, I guess is the best way to explain it.
Bruce?
I don't know what that
is.
is.
I don't know if you've ever used JQ.
No.
Oh, JQ? Oh, you should use it. It's JQ is a command line program for manipulating JSON. I highly recommend it if you do anything via the command line. And
It's like XSLT for
yes,
JSON.
yes.
Oh man.
You're
Yes.
not selling it to me.
Yeah, that was terrible.
Anyway, so basically, most of the advantage of using optics or lenses is when you're working with large, deeply nested data structures. So like they commonly come up in like say like data science or compilers. So like for those application domains, if I were writing like a Haskell book for compilers, I would go all in on lenses. Tell people you got to learn how to do this. You got to pay that complexity price up front, but it'll pay dividends in the long run. If I was teaching Haskell for another use case, I would just say stay away from lenses, not worth the complexity, and so on. So that's why like having that clear use case in mind can crystallize a lot of the educational material as well. And I'd like to make an analogy, like in engineering, it's very common when you embark on a very large project that you first do requirements gathering and then you do design. And the reason you do them in that order is because very often there will be multiple designs for how to do something, and the requirements that you gathered serve as a yardstick for comparing those competing designs and see which one best satisfies the requirements. And so coming up with a motivating use case for the language is like the requirements gathering, and then the design is like the actual pedagogy, material, libraries, and frameworks surrounding that use case.
What's interesting, and I really like this, and I think that this is how we can connect people to something new. Is you have to address it in terms of what problem they're trying to solve. But one of the tensions with this is that oftentimes you are reducing down, like lenses was a great example. You may, for some use cases, not talk about lenses because it's not applicable to the particular problem that they're solving. And what I've seen happen is that people will, in this approach, they'll look at a language and be like, okay, this is what the language can do for my use case, and they compare that with another language, and they're like, well, these are kind of basically the same. And because they've kind of reduced the surface area of this general purpose language down to the way that it addresses their particular problem, it doesn't look super compelling. But they also are only looking at it through one particular aspect of it, and so they're not seeing all of the capabilities that may be useful as they want to address other problems and have a common language that can do other things.
Yeah, but you got to keep in mind that you can't like throw everything. At some point they do a cost benefit analysis, and how much effort do I put into analyzing this language?
Yeah.
Versus.
Well, so I would say, and so this is the second thing from the talk I mentioned, which is that there are two types of adopters. There's early adopters, and then there's mainstream adopters. And one of the key differences between those two classes of adopters is that an early adopter, when they're evaluating any tool, anything they want to adopt, the question they ask themselves is this the best tool for my specific project? A mainstream adopter does not evaluate technologies that way. So they view themselves as belonging to a larger whole, a market, if you will. And the question they ask themselves is this technology or tool the best for the market that I belong to? Regardless of whether it's the best for my specific project, because they want to be able to confidently recommend it to their peers. And so like that is the key thing, the key question they ask themselves when adopting a technology. Can I confidently recommend this to my peers without reservation? Can I say this is really the best option for all of us as a group? And so like that
is much more of an individualistic needs versus community needs.
Exactly.
Well, and I would think that the mainstream adopters would rely a lot on, in other words, not necessarily do all the experiments themselves, but rely a lot on, say, the work that the early adopters have done and the opinions that came back from them. Is that?
Yeah. So this is another key difference between early adopters and mainstream adopters, which is that early adopters, they actually, so the less people use a technology, the more that they like it, because they feel it's a secret weapon. It gives them an edge over the competition because they're not using it. Whereas mainstream adopters are the opposite. The more people that use it, the more they like it, because then they feel like, strength in numbers, better ecosystem, better third-party support, and so on.
So would you say that way back when Java got started, they understood this and they kind of hijacked the process? They go, well, we'll make it mainstream.
Yeah, so like, I was not familiar too much with like how Java was marketed and adopted. I've heard that like they went on like a marketing blitz back at the time. Sun Microsystems did to try and get Java adopted. I would say it's not so much like paid advertising that does it. It's like you need to build that complete experience. People need to feel that this is truly the best solution for the whatever domain that you're marketing it for. And if you can do that, then like it'll kickstart a chain reaction where people will confidently recommend it to their peers. Like that's the key thing. Like you can't really fake it with ad spending, in my opinion.
I think you can't anymore. I think they were able to do it.
Yeah, just all the right things came together.
Mm-hmm.
So another kind of concrete way to take this is Bruce and I and our friend Bill are writing this book about effects systems and effect-oriented programming, and we're using Scala 3 just because that's what we know best. But I don't know if this is true, Bruce. But let's say that our goal is to make the idea of effects be more mainstream. I don't know. First, let's see. Is that our goal, Bruce?
Well, I mean, I always think of the individual reader, and I mean, my goal is to give them an intuitive understanding of, what effects are, why we're bothering with them, and how this is why I keep asking these fundamental questions about it, is because those are the questions that I imagine the reader asking. So that's my goal. You might, I mean, you're, from your position, you might be looking at mainstream marketing or whatever. I'm just saying, get one person on board really clearly, and they will do the work for you. If indeed that's the work you want to do.
So, given that context, Gabriella, any advice for us on how to approach this, how to do it well?
Just to clarify, you're asking like how to motivate effects or how to teach them?
I think
both.
Teach.
We're doing both. I mean, because the teaching, I think to me, you need to motivate it before somebody's willing to put in, because it's a lot of effort. You have to rearrange your brain. Maybe if you've always done Haskell, you don't understand the struggle that it takes to go.
I kind of do, because like I used to do Scala programming at Twitter. I was there for a few years, so like I kind of get it. I think what I would say is, so in terms of motivation, I think the most common application domain where I see effects used is compilers and interpreters. Feels like you very often want to have like, well, specifically because you need to have it's a very technical answer to explain why it commonly comes up in compilers and interpreters, but it does, in my opinion. It's very common. Other application domains, like you could probably get away with just like what many imperative languages do, like language support for exceptions and just ordinary side effects. But yeah, I think like that's the main use case I think that really motivates exceptions. It's hard for me to say. Like, I think the other use case would be like EDSLs. They benefit a lot from effects, but EDSLs are like not really a market. So you'd have to like make
external domain specific languages.
Embedded domain specific languages.
Okay.
So embedded means that like you're still programming in the language. Yep. It's not like you embed some syntax tree in the language. Like you're just writing code.
Yeah.
And so again, embedded domain specific languages is not a market. Like there is no embedded domain specific languages team at a company, right? So as you can't it's difficult to market it, or people don't even know who to recommend it to, because again, it's not a market. Whereas compilers, that's a market. Like companies have compilers teams. Like that is definitely a thing. So yeah, I think it ultimately comes down to.
We're looking at it more from a reliability standpoint, and I think eventually a code reuse standpoint, because that's where I'm coming to.
Like one of the reasons people use effects is to purify code, so make it so that you can like interpret the code without side effects for like testing, mocking, and so forth. I'm kind of lukewarm on that. Like I think it is useful, but I think even if it were really lightweight, which commonly it is not, I think that like there are better approaches, in my opinion. So at some point, I think you want to talk about Dhall, and so like one of the things I think
Yes.
that Dhall does right, which obviates some of the need for effects, is that in Dhall it makes it very easy to interpret code abstractly, meaning that you can actually interpret like a function without even knowing all of its arguments. Like you can interpret the body of the function abstractly. And because of you doing that, it lets you see what the function would do. It's like symbolic interpretation. You can see what it would do under a large variety of use cases without having to like mock the function, right? And I feel like that's actually where the industry should be going, rather than focusing on effects or mocking or testing. We should actually be moving more towards abstract interpretation or symbolic interpretation of code to understand what the code is doing. And then you can imagine then, like, if you want to do a golden test, instead of doing a golden test of like a function input against the function, it's like, instead of doing a golden test of a function, calling some inputs and comparing the output, what you really should be doing is a golden test of that beta reduced function syntax tree, and against like some golden syntax tree. So you could then refactor the function to your liking, but then so long as the function's behavior is intentionally the same, modulo alpha beta normalization, then you should be able. Then you can just diff that against the expected abstract syntax tree, and then verify that the behaviors did not change. In fact, Dhall actually lets you do that. So Dhall like has tooling support for within the language for diffing arbitrary expressions within the language.
So let's back up a little, because
Yeah, I know I introduced several
what
new
is
concepts that we
yeah,
don't-
let's talk about like what. Okay, briefly, what is Dhall, but more importantly, what made you decide that you needed to create it?
So Dhall was not originally created to solve any particular use case. It was actually purely an academic thought experiment. Specifically, on social media, a very common discussion topic that will come up is somebody will say, like, I think my configuration files are getting large and unwieldy, and we should like use a programming language for configuration. So we can take advantage of things like don't repeat yourself, testing, types, and other quality assurance things. And then invariably, somebody will counter that by saying that I don't want my configuration files to be complex, or I don't want them to be code. Like I don't want them to be Turing complete. I think Turing completeness is kind of a red herring here, but that's a very common language that people will use. Like I don't want my configuration file to be able to panic or hang or crash or be unreadable. Like I like plain inert data like JSON or YAML. And so the experiment was like, could we create a language that could thread the needle and give you the best of both worlds? So meaning that like you could still have programming language features, but at the same time still have strong static assurances. So like, for example, you could remove indirection to make the code easier to understand. And the code was like has pure, so like no side effects. So it cannot crash, or it cannot like compromise the host system and so forth. So basically, Dhall is a programming language with a very strong emphasis on language security, so that it's almost as good as inert data. And then eventually we started marketing Dhall for specific use cases like ops in particular. But that was kind of how Dhall's started.
And how do you spell it? And what's the URL for people to look
Oh yeah,
for?
so the way you spell Dhall is Dhall. It's named after a character from my favorite game, Planescape Torment. And the website is spelled dhall-lang.org.
Okay.
So dhalllang.org.
Right.
So I think this is a good time to inject Goetz's law, which is something I tweeted about a couple of years ago, and this is for Brian Goetz. The law that that Brian Goetz came up with a couple of years ago, I summarized as being every declarative language slowly slides towards being a terrible general purpose language. And this is actually based on a couple tweets, one from Paul Chisano, who I'm sure you know. He started with a tweeting something about how Google Cloud had created a workflow system based on YAML. And Paul said, bold idea. When you want to get computers to do something, use a programming language, not a YAML file. And then Brian Goetz responded with where I derived the law from. And he said, every declarative language eventually becomes a terrible programming language, just without the aid of actual language design. We learned this with XML 20 years ago. It astounds me that people seem to think the lesson of that age was that we used the wrong shape of brackets. And I feel like we've been in this tension of like declarative languages versus imperative or whatever. And my interest in Dhall has been that I feel like it gives you the right things that you need, but not more than that. And that there's a lot of places where we need where with those boundaries we can avoid Goetz's law, because for some use cases we really should prevent it from sliding down towards that general purpose language. So configuration is I think a good example of that. There's a few other areas that I'm curious if it would be a good place for, like build tool definition,
Right.
SQL, a replacement for like
I
queries like
think there are
SQL.
lots of places that in fact, like actually, so I think so I'm going to show another of my blog posts, which is I think it's called the end of history for programming or something like that. And basically, I think currently, like the current paradigm of programming is like large general purpose programming languages. And I think where programming will eventually go is a much larger number of smaller special purpose languages. Dhall being like an example of that. Nix being another example of that. And the reason why I believe this is the case is I believe the natural trend of programming languages is to become more and more mathematical, meaning that like non-mathematical details get pushed into the runtime. But in order for those non-mathematical details to get pushed into the runtime, the language needs to become more special purpose. Like the runtime needs to become thick. So many languages currently right now have very thin runtimes. But in order to, like, let me give you a classic example of how languages become mathematical. Memory management, right? So earlier languages, memory management was very front and center in the language. Like, oh shit, here comes a memory allocation. And nowadays, nobody thinks about memory management anymore. It's one of those non-mathematical details that has been
Well,
pushed
you do in
into-
Rust.
Unless you're in Rust.
Yeah, Rust is probably like the one major exception. But I kind of think of like, let me clarify. Like, you still need languages to implement the runtime. I think of Rust as a great runtime builder, right? Not one of those languages that I'm talking about that exists on top of that runtime. But yeah, so basically you need to be able to push. Another example of like an implementation detail getting pushed into the runtime in Haskell would be laziness. So in most languages, evaluation order is something that's very front and center in the language. You have to think about it. In Haskell, the language is insensitive to evaluation order. It becomes an implementation detail of the runtime, what order things are evaluated in. So the programmer no longer has to think about that, and the language becomes more mathematical as a result of that detail abstraction. And I don't think those are the only things that could be abstracted in the runtime. You can imagine things like, to some extent, some of these are already starting to be abstracted into the runtime. So things like logging,
Metrics,
profiling,
observability.
like if you can imagine authentication being like integrated into the language, things like that. And like, but in order to do that,
Effects,
the language no longer be. Sorry, what'd you say?
Effects are another thing that's starting to be integrated into languages or into the runtime of languages.
Exactly. And so, but you can only have those opinionated runtimes if the language starts to become more special purpose and tailored around a very specific use case. And that's where I think we're going to have a sort of era where we're going to have a large number of, you can already kind of see that happening today in one area, which is blockchain, right? So the blockchain industry, we're getting this proliferation of these blockchain languages, but I don't think it will be limited to the blockchain industry. I think we'll start to see the same phenomenon outside in all industries. So for example, you'll start to see languages for programming a distributed system. So like Unison. Unison is an example of a language which is becoming more special purpose towards a specific application. And the main bottleneck here is advances in compiler research and compiler technology. So like frameworks that make it more easy to implement things like especially type inference, interpretation, or compilation, the easier those things become, the more programming languages will begin to fragment into smaller, more special purpose languages.
So a good example of this is Rock. We had on the creator of Rock a while back, and we asked him, do you expect that Rock be built, the Rock compiler be built with Rock? And he's like, nope. Rock is not a language that's created to build compilers. And we were kind of fascinated by that. But yeah, I think that's to your point. Like I think he built the Rock compiler in Haskell, right? Because Haskell is great for building compilers. And so,
yeah. Well,
or was it Rust? Rust or Haskell? I can't remember, but
either one of those. Yeah.
No.
And the do the compiler in the language is kind of a hat trick, and not. I think we've always just kind of considered it, oh, well, you have to do that. But it's like, well, why?
Do you? Yeah. Use a language that's great for compilers and not, Yeah, and Rock is not intended to be a language for building compilers. Yeah, definitely agree with you. So with Dhall, what are the use cases that you think would be a good fit for like that special, more limited language, and how does Dhall avoid that slippery slope down to general purpose?
So for the first question, what use cases that we market Dhall for? I would say ops or DevOps. I think of it more as ops is the big one. So things like Dhall is very commonly used for generating YAML. So things like Terraform, CloudFormation templates, Docker Compose, Kubernetes is one of the biggest one. And a lot of it is due to the fact that because of Dhall's language security guarantees, it provides very strong static assurances, which current tooling does not. Right? Like you can have a much higher like let's use Kubernetes as an example. If you use Dhall Kubernetes package to generate a Kubernetes resource, you have a much higher confidence that resource will be well formed than if you use other tools, for example, like Helm or what have you, or handoff.
It's like static typing, right? It's like one of the benefits of Dhall is giving you static typing, even when your underlying system doesn't have that construct of like the runtime. The Kubernetes runtime doesn't have. It'll try to validate a YAML and be like at runtime, be like, nope, but it doesn't have a concept of a type system around the YAML.
And also, so I mentioned before that Dhall has a strict emphasis on language security. And while that is not strictly necessary for generating, say, a Kubernetes configuration, but that really appeals to ops people because they are people who are very conscious about security concerns. Like usually whenever you introduce a new tool, the very first thing they'll ask is like, okay, like, can this make network requests? Like, can it delete things? And they'll be the first to push back on anything that is too powerful or has too many privileges or permissions. And because
that's one of the reasons why a lot of these systems don't use a general purpose language is because then you have to implement a whole ton of things to make sure that the
tie it off.
The code that you're giving it is not going to do the wrong thing.
Exactly. And so the fact that Dhall gives Dhall's emphasis on language security is a way of marketing to them, just kind of say like, we understand your needs, what makes what you care about, and what they care about is security and like understanding, interpreting, providing static assurances about the code, sandboxing, and so that's just like it's just another clue that they kind of feel like I'm in the right place, and this tool kind of like is trying to do what I'm trying to do here.
And do you think that kind of thing needs to like be designed? That seems like an architectural decision, not something that you do after the fact.
Yes. So, I mean, Dhall's emphasis on language security kind of started from the very beginning. Again, it goes back to that thought experiment. Like, can we get a language which is that balances being inert while still being programmable? And one of the emergent phenomenon of that was that Dhall became a very secure language compared to other languages. But at least that explains how it started that way. Keeping it that way, it boils down to the fact that I did, as the person who created Dhall, I have a lot of influence in the language's evolution, and I constantly pressed against feature requests that would compromise those language security guarantees because I knew that this is one of the key things that our market cares about, and they don't want to see that. Like, for example, like one thing a lot of people would like for other use cases would be the ability for Dhall to be able to run sub processes to like generate Dhall code or Dhall expressions, and that would
Like
greatly
forking out to an external process.
even just like running some shell command to like generate something. And that would greatly compromise the safety of Dhall to the point that so that's the reason why we don't implement that, for example.
That's like there is no way to have effects in Dhall, right? Like you can't talk to the outside world. Is that true?
The only effect you can have is importing Dhall code and via either files or URLs. And if you want to, you can disable the URL imports too, or even the file imports if you really wanted to. But most people don't want that. So
there is no ability to have an effect outside of loading in other Dhall code, and so if you give people an escape hatch where they could do any effect that they want, you've just like open. You've turned Dhall into not Dhall anymore, right?
Yeah,
like you've taken that language security off the table, but that's one of the values of the language is the ability to not do that. The guarantees that you can't do that.
Yeah, so like if you go to dhallang.org, like one of the key sentences on the pitch is that the language aims to support safely importing and evaluating untrusted Dhall code, even code authored by malicious users, and we treat the inability to do so as a specification bug. So we're always hardening the language in various ways to keep that guarantee for end users.
You don't expect to have a log4shell type of scenario with Dhall.
Yeah, so like the log4shell, there were like many aspects of the log4shell breach that were just completely impossible in Dhall, because Dhall actually has many things that prevent those kinds of exploits.
That's great.
So you can import and analyze Dhall code, and then presumably you produce something. You produce what? Configurations?
Yeah, so like so they're conceptually, if you use Dhall to generate, say, YAML, there are conceptually two steps. So there's interpretation, so taking a Dhall program and just evaluating it to an inert normal form. So the inert normal form is still a valid Dhall program. It's just that there's nothing left that can be evaluated in that program. So it could be like a record, right? And then the second step is taking that Dhall expression, possibly a record, and converting that to YAML. And so that two-phase approach is very important, because then it makes it easier for us to roll out multiple backends for Dhall, right? Because then we can just swap out the final step and say, okay, we interpret Dhall, and now we can generate JSON instead, or XML, or a CSV file, and so on.
That's cool.
You could have just used Haskell, right?
Yeah, so like this comes down to the fact that like configuration languages as a market, really that's not a market, but if you imagine if there were, they have some constraints that ordinary programming languages do not. So one of those constraints is that the tool chain for interpreting the language needs to be very lightweight, right? So like let's give an example of where this goes wrong in Haskell, right? There are like xmonad is the classic example of a program which is configured as a Haskell file. And it's very heavyweight. You need to have the GHC tool chain on your system in order to rebuild the xmonad. And that the GHC tool chain is like, depending on how you install it, it could be like gigabytes large, right? And Dhall, and also it's like, dynamically linked. It's very sprawling, and there's several files across the system, and it can, anyway, it's a mess, right? And in contrast, Dhall is available both as a standalone binary. So if you're converting to like JSON or YAML, you can get a statically linked binary ready for any platform. It's very tiny, just a few megabytes, and it does the conversion for you. And you can also embed it within many programming languages too, directly. So then that makes it even more lightweight. It's just like another dependency, which is just, I don't know how much it makes the application binary bigger, but
so one of the motivating factors of Dhall is to have this like lightweight ability to convert from the text form to whatever other form you want.
Yeah. So the key aspect is configuration languages have to be easy to embed. They have to be very lightweight in their implementation. But that also makes it harder too, right? Because if you think about it, like, there are two ways you can do a configuration language. One is a command line tool, which just converts your language to some flat format, like JSON or YAML. That's easier. The hard part is if you want to embed it in a host programming language, because now it not only needs to be lightweight in terms of its implementation, but it needs to be lightweight in terms of its semantics, right? Because let's say if your language relies on a very sophisticated type checker, then you need to implement that type checker in every language that you can embed your configuration language into. So like, if I want to create a Python binding to Dhall, I need to implement Dhall's type system in Python, right? And the more complicated Dhall's type system gets, the harder it is to port to a new language like Python.
So, could you replace Gradle?
I'm not that familiar with Gradle. I can't
Bruce
say.
and I have had some challenges with I think this is more than just Gradle. Build tools have universally done a terrible job at giving us DSLs that find that balance between general purpose language and declarative, you can't do what you need, with Maven on the declarative can't do what you need side and Gradle on the general purpose side. And it feels like Dhall would provide a much better balance for what you need. Like, I don't want my build script to actually, or build definition to be able to make network calls. I don't want that to be possible. I want the safety that Dhall provides in my build definition. So, and I think there is at least one build tool that is using Dhall for the build configuration. Is that correct?
Spago for PureScript. The PureScript build tool uses Dhall as its configuration language, if I remember correctly.
We need to look into that and see how that's working out for them. But
so, you created the language and you're the lead, but it made it sound like there were other people working on it. How many people are working on it?
Governance. Oh, sorry for interrupting.
And also, how do you interact while you're developing?
Yeah, so Dhall has a very formal governance system. So first off, Dhall has a formal language standard, and we have a voting process for amending the language standard. And basically, to get a vote on the standard, you have to have implemented the spec. So every implementation of Dhall gets one vote on any changes to the language standard, including myself. So I as the maintainer of the Haskell implementation, get one vote on proposed changes to the language standard. That said, that's the formal rules for how the language evolves. Informally, like as the person who created Dhall, I have a lot of influence. Like if I push really hard against something, most people will listen to me and not do it. So like there is that informal aspect to it too. But formally, we do have rules in place for how changes are made. And that also appeals to a lot of people too. The fact that like Dhall is not just like, an implementation defined language and that has like rules around language evolution. So like the language becomes much more stable and they know that they have input into the language evolution process. And so I think the governance process does a lot to help Dhall's adoption too.
That's cool. Can I go on a SQL rant for a minute?
Yes.
SQL is terrible. For many reasons, some of which are no static typing, no ability for reuse, and I don't know.
Probably error handling.
Error handling. Yeah, I could go on for a while, but could Dhall be a better query language?
I would say I would not advocate Dhall for this use case. If I were designing a language for this, I would have designed it differently, truthfully. So for example, Dhall has very limited type inference, if at all. And so that makes several things, especially like data processing things, much more heavyweight compared to like the untyped versions. So like if I were really designing for the data science, data processing SQL use case, I would have a stronger emphasis on type inference, even if that meant increasing the complexity of the language, because I feel like that would be kind of a hard requirement for adoption.
That's fair. We recently had on the Flix language creator, and they embedded Prolog. Is it like the Prolog language?
It was a Prolog like. I don't think it was Prolog.
Query.
It was, but a Prolog like language.
Yeah. So they embedded that into the Flix language, but it seems like that is a language that is very much created for queries, and I guess it's fair to say that Dhall's design was not for being a query language. it was much more for being a configuration language. And maybe it really does make sense to have different DSLs for those two different needs. And yeah, maybe I'm trying to do Goetz's law and push Dhall into a more general purpose direction when we need, like you're saying, we shouldn't do that. We should keep Dhall focused on what Dhall is good at and made for, and not try to make it for something else.
Yeah,
I can think of one application domain, which in my view is very poorly served right now. I don't think Dhall should do it, but I think like there is a big gap, which is there needs to be something like a JSON for code, meaning that like some code. I mean, you could technically do this with Dhall, but I would not recommend it.
Workflow. So workflow languages is where you're going. Is this where you're going?
Basically, like some code that you can serialize and transmit over the wire. Like think about like especially like for distributed systems programming, the ability to like send like let me give an example. Like an API, right? Typically, the way you design like some web API is that like if you want to filter the results, there'll be like some pre-built ways of filtering things. Like you'll have like you can provide like various conditionals you can filter on. If you really want to be fancy, you can use like GraphQL, right? But there's nothing where I can just like I cannot just send the server a function for filtering the results. Like that's what I would really like to be able to do. And there's nothing that can do that right now. I feel like that's a really big missing gap in the programming ecosystem.
Yeah.
What is the killer app for Dhall?
I think it's ops. Kubernetes, in my opinion, is the biggest use case for Dhall. I still think there are some key things Dhall is missing to really corner the Kubernetes market. But if there were a killer app, Kubernetes would be the closest thing to one for Dhall.
Okay. Yeah, I'm 100% with that because YAML, I really hate working with YAML. It's not typed. The syntax is terrible. There's no ability for like good reuse. Which I think the ecosystem has kind of built things on top of YAML to address some of those. But I'm like, we should just start at the fundamentals, build something that from the get-go is for that, addressing that need, instead of trying to bolt YAML on top of YAML to make the issues with YAML go away. And so anyways, I think you're right. Dhall is so much better of an option because it gives me the way that I want to work with Kubernetes without having to deal with YAML.
This seems like kind of a PhD dissertation. Is that where it started, or?
No. So like, I actually don't have a formal background in computer science. Like, I actually have a PhD in biochemistry, not computer science.
Okay. So you just self-taught everything.
Yeah, I just self-taught how to do that stuff. If I remember correctly, the way I got into this was I was, gosh, it's hard to even remember, but there are a few like key papers that like really got me interested in this. One was by Simon Peden Jones. It was about like Henk. Let me just see if I can pull up the name. Henk, a typed intermediate language. I think that is, out of all the papers I read, that was the one that like really pushed me off the deep end into learning about all of this stuff.
That's cool. I'll have to do some research on that. I feel like in some ways we've been in the dark ages of declarative languages. It just feels like outside of Dhall, they're just we just keep doing the same wrong thing over and over again, and keep making the same mistakes with declarative languages. So maybe that would be a good transition to Nix, because I don't know much about Nix, but it comes up a lot when I kind of complain on Twitter about declarative languages and other things, I think. So I don't know. You know much more about Nix. Give us the rundown of what Nix is and how it may relate to this conversation.
Yeah. So Nix is, well, so there's Nix, the ecosystem and the ecosystem has several parts to it. So there's Nix, the language, which is a build tool. And then you have Nix packages, the software distribution, which builds on top of that build tool. And then you also have Nix OS, the Nix operating system, which builds on top of Nix packages and Nix. And Nix is designed to be a polyglot build tool, kind of like Bazel or Pants, or I'm not that familiar with the alternatives, but like so it can build a software in multiple languages. And usually that's one of the common reasons why people first reach to Nix is because they start off with their language-specific build tool, like Cargo for Rust or Cabal for Haskell, or I don't know,
Gradle
for Python. Then they need to incorporate other things. And sometimes you can do that using Docker, like one thing runs in one container, one thing runs in another container. But sometimes you actually have a service or a binary where you need to actually incorporate multiple languages into one monolithic executable. And then you need a polyglot build tool. So Nix does very well in that regard. And Nix, I think the main thing that distinguishes Nix from other build tools is it's just way better than the other build tools. So Nix actually did start as a PhD thesis. So Eelco Dolstra's thesis explains the motivation behind Nix. In fact, I highly encourage anybody who uses Nix and hasn't read the thesis to read it, because it does a really great job of motivating what are the problems that Nix solves and why they need to be solved. Huh. So I think he really nailed the motivation for Nix quite well in that thesis. And
that's good to hear that exists, because I think in Bruce and I's challenges with build tools, it didn't seem like anyone had looked at what are the problems that build tools have to solve, and how can we from the beginning kind of design a system that will address those things. And build tools seem to be much more built from starting with one small problem, and then you realize you have this other problem, and so then you like tack on to your build system a solution to that problem, and then it just grows and grows and grows into this monster. And that's kind of the typical path of a build tool.
Yeah, so like in terms of going back to the whole killer app conversation, there are people who have different views on what is the killer app for Nix. My own personal view is that the killer app for the Nix ecosystem is the Nix operating system. I view it as the best operating system for production servers, meaning that it provides, again, for people with a strong emphasis on security, Nix, I feel, does a much better job than other operating systems in terms of security guarantees. Because it was, again, like a lot of things that Nix does lend themselves towards security. So things like, immutable deployments. It's hard to explain all of it. But like, for example, when you deploy, so let me make a contrast to Docker, for example. So one common issue that many Docker containers have, unless they're very carefully engineered, is that the container can be littered with dependencies that are not necessary at runtime. So there's build time dependencies, and then there's runtime dependencies. And it's very common for it to be polluted with build time dependencies. And the way Nix works is that if you build a container using Nix, then you can guarantee that the container only has runtime dependencies. It's an incredibly lean container. It'll be as lean as something that like the most experienced Docker engineer using Alpine Linux could possibly build, maybe even leaner. So Nix.
I've always wondered why operating systems don't have a construct around dependency management. Like I'm so used to in the Java world of managing dependencies in a way, like you're saying, where I can have different dependency graphs that are used, one for build time, one for runtime, one for test, whatever, right? And an operating system has no construct of these things require these things, and they require them at different phases or different outputs or whatever.
But you're saying Nix does that?
Yeah. So like Nix actually can detect, it can very cleverly detect which dependencies are needed at runtime. And then it can, and so whenever you like copy a Nix binary to another machine, Nix has a notion of a closure. So like that binary and all of its dependencies. And Nix can detect what dependencies are build time dependencies and what dependencies are runtime dependencies. So if you copy a closure to any destination or you build a container from it, only runtime dependencies will be copied over when you do so. And also, those dependencies are immutable. So like you cannot accidentally like swap out a compiler with a newer version by accident. You have to like, again, build a new closure if you want to do that. So you can't have like an attack. And the Nix store, when it's not building anything, is mounted read-only. So an attacker, like if they gain access to the system, they cannot just like start tampering with the Nix store and editing your dependencies, for example. So like lots of the small details add up to provide like greater confidence and security. NixOS systems are also easier to audit statically. So without even running a system, so Nix has one of the very compelling features of NixOS is it has a centralized configuration model called the NixOS option system. So literally everything about the system that you can want to configure, you do so using a uniform options interface. So things from like kernel boot parameters to systemd options to like patches for various services to container definitions, like literally anything you can think about. The firewall, you can configure using a uniform option syntax, and you can query it too using the same uniform option syntax. So for example, like if I want to see what ports are open on this system, I can query that without ever building or deploying the system. I can guarantee it'll be exactly these sets of ports. That's a very strong guarantee that's not easy to make with other systems. You just have to like empirically deploy the system, like run an nmap against it to see like what ports are open.
A concept that I've seen kind of emerging lately is the idea of like testable infrastructure. Like, how do you write a test against your infrastructure? Like you're saying, like if I'm doing infrastructure engineering, I would like to write a test that says the only open port is 8080, whatever it may be. Mm-hmm. That's typically really hard with the way we do infrastructure today, right?
I'm going to shill one of my other blog posts, which is called How to Use NixOS for Lightweight Integration Tests. So NixOS has a very great integration testing story. So given a NixOS configuration, it makes it very easy to spin up one or more virtual machines that have those configurations, and then run an orchestration script, which can like do various things to the machines, run various scripts, test various things about it. And it's very great for integration testing, and it can be run safely in parallel. So like I can run a whole matrix of tests of various variations of this that are completely isolated from one another, kind of like Docker Compose, very similar in spirit. But I think the execution of NixOS tests is much better than Docker Compose, in my opinion.
That's cool. So what's the language that Nix uses then for configuration? Or
Nix is the pedantic answer. Really, Nix actually has 3 languages. So there's Nix, the build language, and so like that's the foundation of everything.
For Nix like the build definition.
Yeah, exactly. Like how to build something. Nix packages has an embedded DSL. It's still implemented in Nix for specifying package definitions. And the reason they do this is to make it easier to do deep overrides. So for example, I can say, let's say an OpenSSL vulnerability comes out, and I want to make sure that everything picks up that patch, both at build time and runtime. Like Nix, because of this DSL that Nix packages uses, it's very easy to overlay this deep override to make sure that everything that uses OpenSSL picks up that patch. Similarly, using the same overlay system, I can do things like turn on all security hardening flags for everything that's built with C across the board. Everything will just get rebuilt and pick that up, which is pretty amazing.
Yeah.
So that's the second language. So there's a DSL inside of Nix, which is calling the Nix packages overlay system.
Okay.
And then the third language is the NixOS module system. So the thing for specifying, configuring, and querying those NixOS options. So that's also a DSL, which is implemented inside of Nix. But like you have to also learn that DSL to effectively use NixOS.
Could they have just used Dhall for any of this?
So you can compile Dhall to Nix. So there's a Dhall to Nix executable. That's one of Dhall's many backends. Nice. I would say it's not. I would say that works in the small, but not in the large. So like one of my side projects is working on actually designing a type checker for Nix I guess a language for Nix, a front end for Nix, including type checking, that works well in the large, because Nix is an untyped language, which has some issues as it scales to larger definitions. It does scale. Nix packages is huge. Like it rivals Debian in terms of like the number of packages that they support and maintain. But like again, the lack of types really shows. It's probably one of the biggest complaints people have about the languages. I don't think Dhall would scale to that degree as a front end for Nix.
Yeah, that's cool. Nix. Well, now Bruce, we got to do more investigation on Nix and on Dhall. I think at one point I went looking to see if I could like make my laptop be Nix. like my desktop Linux laptop like be Nix, and I couldn't find it. I couldn't find a way to do that. Maybe it exists, but I was like, I like all the concepts of Nix, but it did seem a little more oriented towards server systems than my desktop machine.
Or
Is
yeah,
that-
maybe
Yeah.
we need to take the lesson from Linux, and it's like, well, yeah, it's good for servers, but maybe Linux on the desktop is never gonna
Hey,
be a
come on!
big thing.
I've used Linux on the desktop for
Yeah, I
a long
know.
time.
I've had that experience. Yeah, well, and trust me, I started trying to use Linux on the desktop back before Red Hat. The first, I kept every year I would try and install it, and it would just you'd always run into this point. They'd ask questions I didn't know how to understand. Red Hat was the first one that would actually go through the whole install process.
Yeah.
So no, I have plenty of experience with this.
Yeah. So could you use Nix? Would you use Nix as an alternative to like Gradle in our world of Gradle or SPT? Like, would that be, or does it not make sense unless you're really doing like with this polyglot build?
So you could, I would say it makes the most sense once you transition to the polyglot build. So Nix packages supports many languages. And so, but I would say, yeah, it's mainly the polyglot use case. Like, I don't feel that Nix as a build tool is the killer app for Nix personally. One of the main reasons why is because Nix does not support Windows. I feel like you can't market to like, this is going to be, a build tool replacement if you don't support Windows.
Yeah.
Or all platforms. It's got to support all platforms.
Yeah. I mean, it does support Mac and Linux, and most Linux
I guess with WSL catching on more, maybe that would give us an option.
But there's still a lot of people who are just going to work in normal. But on the subject, you mentioned like Pants as a build system, and that you could do. It seems like they're trying to expand. What would be a build system that you would choose now if you were doing, say, Kotlin work or Scala work or something like that?
I don't know, honestly.
Oh, okay.
Like, I'm not that familiar with. I would say probably not. The only thing I could confidently say is probably not Nix, and the reason why is because Scala, I think, is one of the few Nix languages which is not supported by Nix. There are some nascent, like Scala to Nix, SPT to Nix tools out there. We actually tried to use them at work. So like we use Scala at work and we use Nix, and they did not work well. They were poorly maintained, low quality, and so we ended up just doing the dumb thing and just having like Nix run SPT inside of a Nix build, and that worked for us temporarily.
Mm-hmm. That makes
Like
sense.
one thing that a lot of people don't appreciate is that like Nix lets you do the dumb thing. So like in the worst case scenario, you can just have like a Nix build which just runs some bash script, kind of like you would in Jenkins, right?
Mm-hmm.
So that's what we do in cases where the Nix support is just lacking for any particular ecosystem.
Cool.
Well, I do need to try out Nix because I used to use Gentoo, and I loved a lot of things about Gentoo, and it sounds like there's maybe some similarities with what Gentoo is doing and what Nix is doing around having an understanding of how a system gets built from scratch and all the dependencies that go into that, and the isolation of different packages is, I think, something I liked about Gentoo. But got to give it a try.
Mm-hmm.
Wow. Well, that has been super helpful. If Bruce and I are going to take some time and go learn Dhall, we probably need to start with a problem that we're solving. And now that I'm not doing so much cloud stuff, I'm not doing Kubernetes much anymore, Bruce, we'll have to figure out what problem we want to solve that could potentially be solved by Dhall. I guess start there instead of just learning the language for the sake of learning the language, which is always fun, but probably be better to start with
some motivation.
Yeah.
Mm-hmm.
Yeah. Do we have any declarative stuff in our book?
Not yet, as far as I know.
All right. Well, I'll have to find a place. So, well, that was fun. Anything else?
Not that I can think of.
Well, it was super helpful. Thank you so much, Gabriella, for joining us, and keep doing the amazing stuff, pushing the world forward into EDSLs and NICs and Dhall and all the other good stuff. But and what is your blog? Where can people find your blog at?
Oh yeah, so my blog is haskellforall.com.
Awesome. Cool. Well, thank you so much, Gabriella.
Right.
You're welcome.
Thanks.